Welcome back to Physics 30. This is the FM2 Dynamics review, so things you need to know for the FM2 exam coming up. So here is a list of all the sections that we did in FM2. So FM2.1, we started off with a general definition of force and went from that, talked about Newton's first law, mass, and then we looked at the remaining two laws, the second law of motion, F net equals ma, and the action-reaction, third law of motion. Then we looked at figuring out weight, Fg, the force of gravity, and also the normal force. So if you look at your little reference sheet here, looking at Fg and looking at the normal force. So this is a key picture right here. Fg and Fn are equal and opposite. Of course, if there's nothing being pulled at an angle, if we have these horizontal forces, which may or may not have friction, Fn and Fg are equal in magnitude, but opposite direction. So we looked at that free body diagram. We looked at solving problems involving Newton's laws and those free body diagram scenarios. And then 2.8. So up until this point, we did frictionless scenarios, not realistic, but a little bit easier in solving questions. And then 2.9 was a bigger section because we looked at friction. Looked at a scenario in which I'm pulling in one direction, friction's working against me. Chances are you're going to have a net force in the horizontal direction if Fa is bigger than Ff. Of course, we also talked about static friction and kinetic friction. So the friction that must be overcome to get it moving initially, and then the friction becomes less once it's moving. So we had coefficients of static friction and coefficients of kinetic friction. Static is always bigger than kinetic because it takes a lot more to get it going than it is to keep it going, an object that is. Then we looked at the inclined plane scenario. So yes, you have access to this. So remember the geometry, the angle of the inclined plane is equivalent to this little triangle here, Fg pulling straight down as always, and breaking that into components. You have a perpendicular to the surface component, which is equal and opposite to Fn, so F normal and F perpendicular. And then F parallel is equivalent to the applied force down the plane due to gravity. So the component of gravity that causes it to go down the plane. So you have this scenario here. So you can easily figure out Fn and Fa by figuring out F perpendicular and F parallel respectively. Okay, and lastly we talked about dynamics of uniform circular motion. So some of the equations up here, 2 pi r over t is equal to speed, acceleration is v squared over r, and then mv squared over r is the centripetal or radial force. So the exam will be an open book exam, be similar in format to what you're used to, except it'll be a little bit bigger since it's open book and you're allowed to use your notes. So multiple choice, 10 questions worth 10 marks. Short answer, 6 questions worth 44 marks. To give you a hint of what those 6 questions will be, the first question, determine the force required to speed up or slow down an object. So you may have to initially figure out what the acceleration is by using some of our older equations, and then from that, F net equals ma from Newton's second law. Number 2, determine the force involved in pushing an object on a frictionless surface and determine the resulting acceleration. So a little bigger question there. Number 3, determine the forces involved when lifting an object. So you could have a tension force by a rope pulling upwards versus Fg. So analyzing the force vertically. And of course, there could be an F net or not. 4, determine the forces involved pulling an object directed at an angle. So it's very similar to this diagram here, except this scenario in which we're pulling up at an angle. So you have to break down the applied force into an Fx component and an Fy component. Then you can figure out the vertical forces and then horizontal forces respectively. And number 5, using the inclined plane one, looking at an object sliding down an inclined plane, using the geometry here, figuring out all the forces, getting the net force along the angled surface here, and figuring out acceleration. And lastly, a qualitative question involving uniform circular motion. So all these questions you've done before in an assignment, so just go back, look through that, see if you can find them. And again, you're allowed to use your notes, so that's why it's a little bit bigger than a usual test that we would do. because you can use your notes. Since it's an open book exam, there is no rewrite because, hey, you should be able to do well since you're allowed to use your notes. Right, if you have any questions, just drop me a line. Otherwise, we'll see you again.